Hey everyone, in this lesson we are going to be looking at how we can create a plugin inside of Godot. Now I mentioned before that every plugin at its core has its editor plugin script, which is basically in charge of loading in the plugin depending on what sort of plugin we want to create. Well, in this lesson, we are going to go ahead and set that up. Now, you may think that we're just going to go down to our file system, right-click, create a new script, but that is not how we are going to do it. The reason why is because the structure of our plugin needs to be done in a specific way, meaning that we need to have a specific folder that we put our plugins in. It needs to be laid out in a certain way, naming conventions. There also needs to be a config file. So how do we create all of that? Well, luckily, we don't actually have to go in and do that ourselves, okay? Godot has a handy tool that we can use to create our basic plugin. So, what I'm going to do is I'm going to go up to Project and then over to Project Settings. And inside of Project Settings, we want to navigate over to the Plugins tab at the top here. And you'll see this is basically where we have a list of all the plugins we have installed, okay? Our own custom ones, as well as any we might download from the internet, okay? So right now we have none. And what I'm going to do is go to the top right and select Create New Plugin. Now, this is going to open up with this menu here. Now, we can enter in a bunch of information for the plugin we are about to create. So here you can see we have plugin name, and this is basically where we can just name our plugin. So I'm just going to call this one test plugin. We can then define a subfolder, so we can just basically call it the same thing, maybe test plugin as well. We can have a description for our plugin, so if you are planning on publishing it, you can add a description here, as well as an author. I'm just going to write down Zenva. You can then put a version number if you wish. You can choose your language. We're of course going to keep this as GD script. And then we can write our script name. I'm going to call this one test plugin as well. Now, if you do leave everything but the plugin name as blank, it will actually go ahead and just fill that information in automatically. So you don't have to define a script name, description, subfolder, etc. All you need to do is define a plugin name and everything else will be generated for you. But of course, you can choose to go ahead and strictly define what each of these things are as well. And then finally, you can decide if the plugin is going to be activated upon creation or not. It's very easy to activate and deactivate a plugin, so this doesn't really matter too much. Okay, so we can then go ahead and once all three of the conditions here are true or green, we can click Create. Now, that's going to do a number of things. First of all, in the file system, you'll see that a new folder has been created called add-ons. Everything inside of add-ons is going to essentially be a plugin, okay? And you can see inside of that folder, we have a new folder called test plugin. If we open up that, we have two files. We have our plugin.cfg and our test plugin script. Now, the test plugin script is going to open up automatically inside of the scripting window right here. So we can see that we have our test plugin script. Now let's also double click on our plugin config file here to have a look at what this is. Okay, now inside of here is essentially a configuration file that contains a lot of the information we defined, okay, the name of our plugin, the description, the author, the version. So for example, description, we could write this is an example plugin. We can fill in the information like that. For the version, we could write down 1.0, and you can of course then update that as you continue on. And script right here is going to reference the script that we want to basically run when our plugin is enabled, okay, which is testplugin.gd, and that of course points to this script right here. Now, how do we actually go about turning on and turning off our plugin? Well, if we go up to Project Settings, you'll see that our plugin is now in the plugins list. And you'll see on the left-hand side, enabled is set to be on. Now, if we click that, that is going to turn off our plugin. So if we had a custom window setup, if we had a custom inspector and all of that, that would then, make those things vanish or go away. Whereas if we enable them, that will then bring them back. Okay, so you can turn on and turn off plugins as you see fit. Now, I'm just going to turn it off for now, and then we are going to go back inside of our script here. Now, there are a few things that we need to have a look at inside this script. First of all, you'll notice that there is this little attribute or line of code at the top called @tool, okay? What does this mean? Well, essentially, when you tag a script with @tool, this means that its functions have the ability to run inside of the editor. Because by default, every script, every function is only going to run when we click on the play button, okay? But if you tag a script as a tool, this means that these functions have the ability to then run during the editor when we're editing our game in our scenes. So that means if we have the process function, that would then also be running every frame, no matter if we are in the game or not. You'll then also notice that we are extending from editor plugin, okay? This is required in order for us to have this script. And then down here, you'll see the two functions that have been created for us initially. Okay, we have enter tree, which gets called upon the initialization of the plugin. So any code that you want to run when the plugin is first initialized, such as instantiating scenes for the dock, setting up anything, adding your custom nodes to the menu, stuff like that, that is where you do that here. And then exit tree is what gets called when the plugin is then disabled. This is where you'll then delete the dock. This is when you would then remove the node from the node list if it's a custom node, or when you would remove the code from the custom inspector, okay? So you can see sort of how this editor plugin script isn't really the underlying logic for our plugin, but rather it is loading in the plugin and then it is unloading the plugin, okay? Because with our plugins, remember, we had so many different types. I think I listed about 6 of them. This plugin script right here is kind of independent from all of those. And then within this script is when we then load in the scene and the other scripts that then run that code. If it be a custom node, if it be a custom dock, extending the inspector, okay? So this editor plugin script is again loading in our plugin and unloading it here when we disable it. Now let's see this code in action. So inside of enter tree, I'm just going to print a line of code here which says plugin has been enabled, and then down here in exit tree we can print out plugin has been disabled. Okay. Now if we open up our output and we open up our project settings, if we go ahead then and turn on the plugin, you can see it says plugin has been enabled, and then when I disable it, plugin has been disabled. Okay, so that code is working. This script here is running when we are enabling and disabling our plugin, so that is good. Now from here you can do a number of different things, okay? You can go ahead and create a custom node, okay? You can create a custom dock, you can create a custom main screen, you can create 3D gizmos, you can create import plugins, all sorts of different plugins and ways to extend Godot's editor. Now in the next lesson we will begin looking at how we can start to create these more specific type of plugins. So thanks for watching, and I'll see you all then. Hey everyone, in this lesson we are going to be looking at creating a plugin that will allow us to implement our own custom node. Okay, so what I'm going to do first of all is I'm just going to go ahead and create ourselves a UI scene right here. Let's just call this main, and we'll just save this, to our project as perhaps, here we'll go custom node test. Now, typically, when you go to create a node, you'll click on the plus button right here, and you'll have your list of all the different nodes that Godot has to offer. Now, Godot has a lot of different nodes, hundreds probably, but there might be a node that, doesn't quite fit what you want to create. So what we're going to look at in this lesson is going to be going over creating our own custom node and even giving it its own custom icon. So the node we are going to create is going to derive from the button node. And this is essentially going to be a button that when we hover over it, it is going to enlarge, and then when we move our mouse away from it, it is going to go back to its original size. So it's going to be a bit of a dynamic button, I guess you could say. And eventually we'll be able to open up the create new node window and find the hover button in this list right here. So that's going to be pretty cool. So let's start, of course, by creating our plugin. So for this, we're going to go to project settings, go over to the plugins tab and click on create new plugin. Now here we can give our plugin a name. I'm going to call this one hover button. The subfolder is going to be the hover button subfolder. We could write a description. We could go button that enlarges upon mouse entering. Author, I'll write down Zenva. Version 1.0. Language, GD script. And the script name, we can just call this one hover button plugin, since this is going to be loading in the actual button itself into the node list. Activate now, we'll just keep that enabled, and then click create. So here we go. We now have our plugin created. The first thing we need to do though is actually go ahead and create our button script, okay, the actual script that is going to run on the node. So for this, what I'm going to do is go down to add-ons, and you'll see we have the hover button folder, and inside we have our hover button plugin, which is what we have open right here, essentially the script that loads in our plugin. We have our config file, which contains all of the data for our plugin. And then what we're going to do is actually go ahead and create the button script itself. But before we do that, I am going to import an icon. Now, in the course files tab, there is a zip containing a lot of the assets that we're going to use for this course. Now, they are not required. They are just there if you want to have some nice visuals for when we are developing our plugins. Now, inside of it, you should see a hover button folder. And inside of there, we have this hover button PNG file. This is essentially going to be the icon we're going to have for the node. So I'm simply just going to drag that into the hover button folder right there, and there we go. Now the next step is going to be creating our hover button script. So I'm going to right click on the folder, create new script. I'm going to call this one hover button, and it is going to inherit, if we click on this little hierarchy icon here, we can search for button and select button right there. Click inherit, and then click create. So we've now gone ahead and created the hover button script. Let's open that up and begin developing. So the first thing we need to do is actually define how this script is going to work. Now, essentially what we're going to do is if we just go to 2D mode here and have a look at the existing button. So let's create a new child node, create a button. Okay, and we'll just say click. So this here is our button, okay, and this is essentially what we are going to be modifying. So our node is going to derive from the button here, and essentially what we want to do is when the player's mouse enters the button, we want to essentially increase it in size. Now we could go ahead and increase its actual size in pixels, but the issue of that is if you have it sort of arranged in a container, that can mess with a few things. So instead, we are going to modify the button's scale. So if we go down into the inspector, down to layout, down to transform, and then down to scale, you can see by default it is at 1. Now if we increase this to something like 1.1, you can see the button is a bit bigger, and then it can go back down to being small. So when we hover our mouse over it, the button is going to enlarge slightly. Then when we click, it's going to go back to its original state. When we unclick, it's going to go back to being large. And then when we hover out of it, it is then going to go back to its original state as well. Okay, so it's going to sort of be dynamic based on our mouse position and clicks. But one issue is that if I modify the scale, you can see that it doesn't really scale it from the center, it scales it from the corner here, and that is an issue. So what we're going to do is also in our script is modify the pivot offset. Okay, this little plus icon right here defines essentially the origin or the center of this control node. Now we want this to be in the middle. So what we need to do is essentially get our size and divide it by 2. So our X size right now is 72 pixels. So our pivot offset is going to be 72 divided by 2. And our Y is going to be 33 divided by 2. So now if I increase the scale, you can see it is sort of scaling up from the center, which is what we want. But if we resize our button, you can see that the pivot offset does not change. So we're going to have a dynamic pivot offset that is going to change when we are modifying it in the editor as well. Now, in terms of how we are going to be detecting when the mouse is entering and exiting this button, that is going to be done through signals. Now, the button already has a number of signals that we can modify. For example, we have button down for when we are clicking down on the button, button up for when we are no longer clicking on the button, when we remove our mouse. We then have a mouse entered, mouse exited, and to detect when the button has been resized so we can adjust our pivot offset, we are also going to be listening to the resize signal. Okay, so that's 5 different signals we're going to be listening to. So let's hop over into our script now and begin setting that up. So I'm going to go ahead by creating a number of different functions. Well, first of all, going to have mouse entered, which is going to be called when our mouse has entered the button. Likewise, we're going to have mouse exited, which is going to be called when our mouse leaves the button. We then want to have button down, which gets called when our mouse is over the button and we have clicked down. Okay, so that is going to basically change its size as well. And then, of course, we have button up, which is going to be called when our mouse click is let go. And the final signal is going to be the resized signal. And this, of course, gets called whenever we have modified its control properties here in the editor. So now what we need to do is basically connect these functions to our button's signals. And since we are extending from button, we can do that inside of the script. So I'm going to create the func enter tree function right here. Now, enter tree gets called when this button is added to our scene tree here. Okay, it's not going to work if we use the ready function because that is really for in-game initialization. So enter tree, this gets called when the node is added to our scene tree. So we want to connect the button signals to these functions here, and we can do that by going mouse entered. Okay, you can see we'll select the signal dot connect and then the mouse entered function. Okay, now let's do that for all 5 or all 6 of these. And there we go. So now all of our functions here are connected up. And also at the start of when we have entered the tree, we also want to call the resized function, okay? And the reason why is because from the very beginning, we want to have the pivot offset in the center, okay? So that is not actually going to get called, this signal, until we go ahead and modify this. So calling this at the start is just going to automatically pinpoint the pivot to be in the center. Now, we're of course going to see how this all works in action later on when we actually add in the functionality, but in the next lesson, we are going to begin adding in some variables and connecting this up to our hover button plugin. So thanks for watching, and I'll see you all then. Welcome back, everyone. In this lesson, we are going to continue on developing our hover button plugin. Now, the first thing we need to do is actually make it so we can find and create our button inside of the create new node window. So to do this, what we're going to do is we are going to go over to our hover button plugin script. And down here where we have the enter tree function, we are going to go ahead and write this line of code. We're going to go add custom type. Now, with this, we need to define 4 different parameters. First of all, the type that we are going to be creating, which is going to be hover button. We then define a base, so what is it inheriting from? That is going to be button. And then we need to define the script that is going to represent this node. That is going to be preload. And then we just want to find our hover button.gd. And then we need to define an icon, okay? Now this icon is going to be our hover button PNG. So we'll just go preload and give that the hover button.png right there. Okay, so once again, we have 4 parameters for add custom type. We have, first of all, the type itself, which is hover button, what it is derived from, which is the base button. We then have the actual script itself that we want to represent the node. And then we have the icon, which is that PNG file. And then down here inside of exit tree, we essentially want to remove the custom type. So here we'll go remove custom type, and we just want to define that type as hover button. So if we were to disable this plugin, we would no longer be able to create this new node. So now what we can do is go back to our 2D scene here. Let's delete this button we have that existing, and then we're going to go project settings, and over here we want to basically disable it and then re-enable it, okay? It's important to note that whenever you make any changes to your plugin, for those changes to be visible, you need to disable and then re-enable your plugin. Now, if we go ahead and click on the plus to create a new button, you can see if we search a button and then look, you can see down here, hover button, okay, which is great. Now we can click create, and that is going to create the hover button right here. So now what we need to do is start setting up the code for the functionality of this button, because right now, if we save this and press play, you'll notice that it just behaves like a normal button. That's because we haven't added anything new on top of it. So the first thing I think we should do is work on setting up this pivot point to always snap to the center of our button no matter how we resize it. Now, how can we do this? Well, if we go to our script, our hover button script, you'll notice that we have already connected the resized signal, which gets called whenever we change the control, to the resized function down here. Now, the code for this is pretty simple. All we are going to do is get the pivot offset.x and set this to be size.x divided by 2, okay? We are essentially getting the width in terms of pixels of the button, dividing that by 2 to get the center. We then want to do the exact same for the y, equals size.y divided by 2. So we can save that. Now if we go and basically enable and disable the plugin, you'll see that it doesn't work. So why is it not working, even though we have connected the signal? That is because, remember, by default, every function inside of our Godot script is only going to run if we press play. So if I press play right now, then yes, that is going to be able to run, but by default, that is not the case. So what we need to do is at the top of our hover button script, we need to add the @tool attribute, and this is essentially telling Godot that we want these functions running during the editor and not just during runtime. So what we can do is go project settings, enable, disable again. Let's actually go ahead and recreate that button. So hover button over here. Now you can see by default the pivot point is in the center, and if I go ahead and change its size, you can see that is going to dynamically update where that pivot point is, which is great. So now when we scale it, it is going to scale from the center out. Okay, so the next step is now going to be having code run when we enter and exit our mouse. So we're going to start by creating some variables. The first variable is going to be one called target scale. This is going to be of type float, and by default, it will be equal to 1. This is essentially the scale that our button is going to try and achieve every single frame. We then want 2 more variables. These are going to be export variables, meaning they are going to be visible in the inspector. The first one is going to be called hover size, and this is going to be of type float, and by default we'll make it 1.05. So this is essentially the scale we want to move towards when our mouse has entered the button. And then we want another variable called resize speed of type float, and this is going to basically be how fast that button is going to scale up and scale down. So these 2 things we can then modify in the inspector as we see fit. Then what we're going to do is go down to the process function, which we don't have yet. So let's go ahead and create the process function. So func process. And inside of here, we essentially want to change the scale every frame based on our target scale. So first of all, we're going to create a variable called t, which is going to be basically the amount we're going to lerp. This is going to be resize speed times by delta. And then we are going to go scale.x equals lerp scale.x to the target scale by t. Okay, so essentially every frame we are going to be changing our x scale to try and meet the target scale at a rate of t, which is going to be based off our resize speed. We then want to do the exact same thing for the y scale as well, and there we go. Now, there's going to be one little issue that is going to be a bit strange, but if I go ahead and show you, for example, let's reload the plugin. Okay, so if I go ahead and recreate this button, just because we have this new code initialized, so hover button, if I go ahead and resize it up, move it over here, and then if I go down to where we have layout, transform, and then modify the scale, you can see that it is sort of modifying the scale in the process function, even in the editor. And that is of course because we have defined this script as a tool, meaning that even the process function is going to run. So every frame, it is still checking and lerping the scale, which you might not want in the editor because you kind of want to be able to modify these values without them automatically adjusting. So what we can do is make it so that the code here inside of process is only going to get run during runtime, even though we have the tool attribute assigned here. And what we're going to do is we are going to write this. We're going to go if engine.isEditorHint, then we're going to return. Essentially, this function right here returns true if we are currently in the editor and false if we are not. So now, if we go back inside of our scene here, and resize the scale, you can see that is going to be resized nicely. But if we start off with a very large scale here and press play, it should actually then lerp back down to 1, which it does. Okay, so there we go. That works nicely. Welcome back everyone. Let's continue on with developing the functionality for our hover button. So what we need to do now is set it up so that when we hover over our button with the mouse entered signal here, we set the target scale to be the hover size. Then when we exit, we want to set the target size to be 0. When we press down, target size 0, and when we release our button, target size goes back to the hover size, okay? Sounds a bit confusing, but basically this will make it so that when our mouse enters the button, it'll go big. When we click, it'll go down. When we release the click, it'll go back up big. And when we remove our mouse, it will go back to being its normal size, okay? Again, probably a bit confusing, but let's just fill this in and hopefully seeing it in action will make sense. So, with the mouse entered function, here we are basically just going to go target scale equals hover size. Then with mouse exited, we'll go target scale equals 1.0, so basically it's default scale. Button down, we'll go target scale equals 1.0 as well. And finally, button up, target scale equals hover size. Okay, so we can save that. Now, if we go back into our 2D mode here, and if we go ahead and reload our plugin, we should then be able to, if we select our button, let's resize it, let's give it some text, so we'll say click, okay, make it a bit bigger, move it over here. Now, if we press play and hover over the button, you should see that it increases in size a little bit, okay? It's kind of hard to see because it's pretty small, but when I hover over it, you can see the button increases in size. And then when I click, it goes down, okay? So that is essentially the hover button that we have here, okay? So everything is working as it should. But one thing you may notice is that when I click on the button and then drag my mouse out and release, you can see that it increases the size again, okay? Which is something we don't want to do. So to fix that, we're going to go back to our script and we're going to create one more variable here. This is just going to be called mouse over, okay? So this is going to be a boolean. And this is basically going to be true for when our mouse is over the button and false when it is not. So here, mouse entered, we'll go mouse over equals true. Mouse exited, here we'll go mouse over equals false. And then down here, when we release the button, we are going to check. If not mouse over, then we are going to return, okay? So we're not going to modify this. So if we press play again, you should see that we can click like normal. This time, when I click and then drag out, nothing happens, okay? The button doesn't go back to being big. So that is how we can fix that little bug. We can also tweak some of the settings here. For example, the hover size. If we make this 1.2, that means essentially the button is going to hover and get a lot bigger, as you can see here. We can also then change the resize speed to maybe 50, and this is going to bump up its speed. So there we go. You can see the button's going pretty wild right there, so we can just undo those changes. And yeah, that is our hover button. Now, the next step is going to be setting up our custom icon, because if we go, for example, if we create a new node, you'll see here that the hover button does indeed have the icon in this window. But when we create the node, it doesn't. It has the default button icon. So how can we actually go ahead and give this node the button icon? Well, for that, we are going to go to our script where we have our hover button. And at the top, we are going to add another little attribute tag here. And this one is going to be @icon. Now, @icon, we basically just give it a file path to an image. So in our case, this is going to be our hover button. So I'm just going to drag that in, and that is going to paste the link to it, okay? So we can save that, go back into 2D, we might then go ahead and reload our plugin. Okay, it's not there, that's fine. If we go ahead and delete that, create a new hover button, it's still not there. So what's going on? Well, essentially what we need to do is we need to go ahead and restart the editor, okay? And that's just because the way Godot loads in all of its icons for the nodes here, we have to restart the editor so that this hover button can then be loaded in, okay? So simply do that and we'll see if it works. Okay, and after restarting the editor, as you can see, we now have our special hover button icon working, okay? So when we click on it, you can even see next to the script name, it says hover button, and then we have this icon, okay? So everything's working great. So now you can basically install this plugin, you can add it wherever you wish, if you want to easily implement this new hover button plugin. And likewise, you can do the exact same thing with all sorts of nodes. If, for example, you wanted to extend the character body node to have more functionality and have that as its own separate node, then you can of course do that. Or you can create your very own character controller node that you might want to then put out there as a plugin for people to download and use, okay? There's lots of different things you can do with this. As you can see here, we just created a little example with a button, but you can do all sorts of other custom UI elements, all sorts of other custom nodes that might incorporate certain features that you want inside of the engine. There's really an unlimited number of things you can do with custom nodes. Welcome back, everyone. In this lesson, we are going to be looking at setting up and installing GitHub Desktop. Now, what is GitHub Desktop? Well, originally, we first of all created our repo on our GitHub website here, which is great. We have the repo here, we can see the files, but how do we actually go about adding our Godot project, and how do we go about actually tracking whatever changes have been made? Well, we could click on the add file button right here and upload our Godot project, which would work, but then whenever we make changes to that project on our computer, GitHub would not know those changes have been made because it's not connected to that specific directory on a computer at all, okay? It's basically us uploading to Google Drive or uploading to some server. So what we need is a piece of software that is installed on our computer that can detect those changes that have been made to whatever directory we have assigned, and then be able to commit those changes and then push them to the repo here on GitHub. Now, GitHub thankfully has a piece of software that does exactly that, which is known as GitHub Desktop, okay? You can find this by going to desktop.github.com/download, or just Google GitHub Desktop. So we're going to go ahead and click on the download button right here, and that is going to begin the download process. Okay, so once you have installed GitHub Desktop and have opened it up, you should be presented with a screen that looks not exactly similar to mine, just because I already have some repos attached to it, but you should have generally the top buttons up here. Now, the first step is going to be connecting GitHub Desktop to our GitHub account. So what we're going to do is go up to File, then down to Options, and then in Options, we want to go to Accounts and click Sign into GitHub.com. Okay, we can then click Continue with Browser, and this is going to take us to GitHub, where we can then choose to continue as this account right here, and then that should then take us back to GitHub Desktop. Okay, and there we go. So now if we go back to File, Options, you should see that you are now logged in to your GitHub account. Now, something else we want to do is then go down to where we have the Git option right here, and this is where we are going to basically choose the name that we are going to commit with, okay? Because every time you commit changes to a repo, you need to have a name and an email. Now you can just specify your name right here, basically just so we know who is actually committing these changes. And the reason why it's separate to the account is because you can have, I guess, different names for different computers as well. So just add your name here and just add your email, although it should be done automatically for you upon logging in. But if you wanted to have a more specific name, you can change that here. So we're going to click Save. And then the next step we want to do is connect our repo from GitHub to our GitHub Desktop app. So what I'm going to do is at the top left corner, I'm going to go File and then go down to Clone Repository, okay? Clone Repository basically means we are getting a repository that we already have created and basically cloning it on our computer, okay? We are basically pulling that repo, storing it on our computer, and then keeping note of where that repo is. So when any changes have been made to it, this app will be able to notify us and have those changes be committed. So what we're going to do is select our repo. So I'm going to select my first Godot project right here. We can then choose a path. So I recommend creating a folder called GitHub on your computer and storing all of your GitHub projects there, okay? So we can then click on clone, and that is going to go through the process of cloning that. So downloading the repo from GitHub, downloading those files and storing them in that directory. And then we should see here that we have this screen. So the way this screen works is on the top left, you can see we have our current repository set to my first Godot project. We can then see a list of all the changes that have been made. Now, so far, we have not made any changes to this repo, so that's why it is empty. We can also click on history, and this is going to show us a list of all the original changes and pushes that have been made. So if you remember, we have our initial commit right here that was made by me automatically. We can click on that. We can then see the list of all the files that have been changed, so the .gitignore, and then we can see also then the changes here. So it's very similar to the GitHub website. Now, when we go back to changes, whenever there are files listed here, we can click on those and see the changes displayed here in the center. But right now, let's actually go ahead and look at our project inside of our directory. So the easy way of doing this is by right-clicking on the top left where we have our repo name and going to Show in Explorer. This is going to open up our file explorer. You can see we are at github/myfirstgodot and inside of here we have our .gitignore. So we can open this up, and if we were to go ahead and make changes to this, those changes would appear here. We can then commit those and push those to the repo. But we don't really want to modify our gitignore here at all. So instead what we're going to do is, let's just say we want to create a new file. So I'm just going to right click here, go new, and I'm just going to create a text document. And this one is just going to say, let's call this one example file. Let's go inside of this and just say, this is a file testing out our commit, okay? Just something like that, very simple. So we can save that. And then if we go back into GitHub Desktop, you'll notice that, oh, we have one change, and that is example file.txt. We can then see a list of all the lines that have been added. So we've added 2 new lines. And then what we can do is, if, for example, we've finished working on our project for a while, we might want to go, all right, I've worked on this project for a couple hours. Now it's time to push our changes. Well, what we can do is go down to the bottom here. We can enter in a commit message. So this can be, for example, added example file. You can be a bit more specific if you have a bunch of other changes made. You can also add a description, which is going to be a much more detailed overview of the changes that have been made. But do note that if we go to history, you can see here, it's only the name that you'll see, okay? So don't make your names too vague. Try and add descriptive words to your commit messages, as that is what you're going to be seeing. The description is if you want to go into more detail, okay? Be more specific. So once we've done that, we can click commit to main. Main is essentially the main repo branch that everyone's going to be committing to. But this has not done anything to our repo, okay? A commit is only a local change, okay? So we're only making a change locally on our computer. If, for example, we wanted to push this to the repo, then we would have to go to the push origin button up here. You can see it has one commit waiting. So it will push to origin, and that is going to basically push that change to the repo on the GitHub website. Now, if we go over to the history tab, you can see here we have our new commit applied. Okay, so in the next lesson, we are going to be going over connecting our Godot project to GitHub. Thanks for watching, and I'll see you all then. Welcome back, everyone. In this lesson, we are going to be looking at how we can add our Godot project to the repo. Okay, so you may already have a Godot project you've been working on that you want to connect to a Godot repo, or you might be wanting to create a brand new project. So what I'm going to ask you to do first is, first of all, locate your Godot project or create a new one and then open it up inside of the File Explorer. So on the left-hand side here, I have my GitHub repo. Remember, we have the .gitignore and we have that example file that we created. So this file directory is where we are storing everything we want to change and upload to our GitHub repository. On the right-hand side, this is inside of my Godot project itself, okay? We have the Godot folder, we have assets, we have our project file, and everything else. Now, you may notice that when you create a new Godot project, you have these 2 files. You have .gitAttributes and .gitignore. Okay, Godot already knows that people are going to be using GitHub for their projects. So thankfully, they already include some of these files. But what you'll notice is that with the Godot's built-in gitignore file, it's pretty simplistic, okay? If we look at this one compared to the one that we created with GitHub, you can see that the GitHub one features much more. So what I'm going to do is I'm going to go ahead and delete the one that we have in our existing Godot project, since we don't want to bother about merging the 2 together. You'll also notice that we have a .gitAttributes file. Now, this one basically just determines how certain files based on their file type are going to be merged, okay? We don't really need to worry about this too much as we can just keep the default one Godot has for us already. So we're not going to explore too much about that. And secondly, the way we can add our project is by just selecting all the files and folders inside of our Godot project and dragging them over. So I'm going to drag them into my repository here. And now our Godot repo is going to essentially act as our project file. So if we want to edit this, we'll have to open up Godot and then open up the My First Godot project folder, as that is what contains our Godot files. So if I go back into GitHub Desktop, you'll see now we have a large list of all these files that have been added and or changed. But since we've dragged over a lot, we're basically adding all of these files here. Now, just like with the git ignore, we can click on a file to see its content. So if I click on the license here, we can see the license content. If we click on images, you can even see what the images are, which is pretty cool. So you can see exactly what assets you are importing. If we go down here, you can see if we have an MP3 file, these cannot be changed, okay? Binary files, since they don't really work in lines, as everything else here you can see, is basically, or aside from images, they work in a line format. Since binary files don't really have lines, they're just one big block of data, we can't really display them here, okay? And that is because Git is originally designed for programming, and programming works in lines of code. So that is generally the format that the software likes the best, okay? But it also works for MP3 files, and pretty much any file type, okay? Just if you're trying to merge two files together, it is going to be able to do that fairly easily with text because, as you can see, everything is divided up into lines, whereas with something such as MP3s or binary files, it's going to have trouble merging those, but you're not really going to be making little changes to bits of an audio file, okay? You're always going to be overriding it, so that's not something we really have to worry about in Godot. So now what we can do is go down, we can give this a commit message, so I am just going to call this one added Godot project. We could give a description if we want, but not really much more to explain. And then I'm going to click on commit to main. Okay, and that's going to go through the process of committing all these changes, so compiling that into a single commit. And then once that is done, you can see we can click on push origin. And this basically means we are going to push that commit to our repo. Okay, it's pushing it to the GitHub server on the internet. So that may take some time depending on how many files you have and the file size, but as you can see, there we go, it is now done. And if we go over to history, you can see here we have added Godot project, and it is of course going to show us all the changes that have been made. And if we even go back to GitHub on the website and we refresh our repo, you can see now that we have everything added here, okay? So we have our files, we have our folders that we can open up and explore. So you can see now how this sort of acts as a file explorer, okay? We can go in, we can navigate through all the different assets, we can even open up the images here, and they get displayed nicely, okay? So if you did want to share this around with people, they can easily jump in, see your code, especially if it is a public repo, okay? People can see how you structure your projects, how you write your code, and everything that is involved. Now let's go over actually opening up this project in Godot, because we just copied over the files, but you know, if we open up that project, it's still going to open up the original. So here I am inside of Godot. And what I'm going to do is click on the import button right here, and I'm going to navigate over to my GitHub folder. So I'm just going to go over to the correct drive, go to GitHub, and then you can see here we have my first Godot project. So I'm going to select that, which is our GitHub repo, and click select this folder. Click import and edit, and that is then going to open up that Godot project. And there we go. So now any changes that we make to this project, if we go over to GitHub Desktop, they should appear over here in the change list. But since we haven't made any changes just yet, we don't have to worry about that. But in the next lesson, we are going to be going over looking at how we can make changes to our project, how we can then push them here inside of GitHub Desktop, and then in the future, looking at what happens if two people are collaborating on the project and they make changes that intersect with one another, which are known as merge conflicts. So thanks for watching, and I'll see you all then. Welcome back, everyone. In this lesson, we are going to be looking at making changes to our Godot project and seeing those changes before we commit them. So what we are going to do is we are going to look at creating new files, modifying files, and deleting files. So what we're going to do first of all is go ahead and create a new file. So let's just say we want to create a new script here. I'm just going to go ahead, right click, create new script, and I'm just going to call this one simple. I'm just going to call it simply test script, just so we can see how it appears inside of GitHub Desktop. So we got our test script right here, which has the default code written out for us. Now let's look at it, what happens if we go ahead and perhaps modify an existing script. So I'm just going to go ahead to one of the scripts we have here, and let's just say we want to, for example, add in a new line of code. So let's say over here, we want to put in a print line. So we might go print, and then this could say add gravity. Now, how about deleting a line? Well, let's go to another script. So here we can just maybe delete this function right there and save that. Okay, now let's go over into GitHub Desktop again, and you'll see we have these 3 changes. Now you can see that 2 of them have this yellow icon, which means it has been modified. Green means it is new, and if it is red, that means it has been deleted. Let's actually go ahead and delete a file, just so we can see that. So we'll just go assets, and let's just delete one of these random tiles here. Okay, we'll just go ahead and delete that file. So if I save this and go back into GitHub Desktop, you'll see now we have deleted a file. Okay, we have the PNG file here, which has been deleted. And also its import metadata as well. So you can see here, when we click on the script, we can see that new line of code that has been added, and it shows us with this little plus icon, which is very handy. Same thing for the other script where we have deleted that chunk of code. It is in red, so we can easily see what has been added and what has been deleted. And of course, this script here has been modified as well, or has been created. So we can go ahead, give a commit message. Let's just say testing out GitHub. You know, probably want to be a bit more specific if you are, of course, creating scripts and modifying them. We can click commit to main. And then once that is done, we can click push origin, and that is going to then push those changes to the repo. And then if we go to history, click on testing out GitHub, we can see all of these changes right here. Okay, so you always are going to have this large history that you can go back and check. So if there are any issues in the future, or if somebody accidentally deleted a file or modified a certain line of code, you can always go back and look at how that change happened and where exactly it occurred. Now, as a bit of a challenge, if you are following along, I want you to go ahead and set up your Godot project inside of GitHub if you haven't already done that, and then I want you to go ahead and begin creating some commits, changing some files, committing those to the repo. Hey everyone, in this lesson, we are going to cover the concept of singletons inside of Godot. Now, typically in other game engines and other programming languages, the concept of a singleton is something that is more scripting or programming specific, whereas the Godot engine has decided to make the singleton pattern built into the engine itself. Now, this has many benefits. The main one being that we don't have to go in and actually code the functionality around this, and the fact that since it is built into the Godot engine, all of the edge cases are going to typically already be covered. So, what is a singleton? Well, a singleton basically makes it so that we have a script with a single instance across the entire project, okay? Because right now in our games, we have scripts such as player, pickup, score text, you know, all those things. And a singleton will basically make it so that one script, let's just say we might have a game manager, well, that script is no longer actually going to be attached to a node in our scene. Rather, it is now going to exist sort of outside of our scene structure. It's going to sort of exist above it as its own singular instance in memory. And whenever we want to utilize that script, it can run as a normal script does. We no longer need to access it by getting the node. Rather, we just directly write down the script name to access its properties and functions. Now, why is this a good thing? Well, let's just say, for example, we have a script in the example we have right here, which might keep track of our player's score. Okay, so let's just say we have a score manager. And if we look here, I've gone ahead and created a script called score manager. And you can see the only thing in this script we have is a variable called score. Well, Let's just say we then have a little game like this, where we want to go around and we want to pick up these things. You know, we might defeat enemies, pick up stuff, to increase our player's score. Well, what happens if we then load into another scene? Well, that is then going to basically delete all of the nodes that we currently have in this scene, including the player, the pickups, and even the score manager itself, okay? So in this example here, I basically have it so that when I press enter, it is going to reload the scene, and you can see, as you expect, everything basically gets reset, even our score. But in many games, we want our score to persist across scenes, okay? Level 1, level 2, level 3, we want our score to remain the same. So how can we do that? Well, what we would then do is turn our score manager script, which is keeping track of this variable, into a singleton, so that no matter what happens, if we reload a scene, if we delete a scene, if we go to the menu, this score manager script is going to maintain its existence in memory, okay? And thus keeping the score variable constant. So before we look at how we can convert this project over, let's first of all look at what this project is, okay? It's just a little game I've set up. So basically we have a player down here that we can control with the arrow keys, and attached to this player is a player script. So if I have a look at that, basically we have the ability to move our player around with the keyboard and also flip the sprite direction, okay? Just some little touches there. And then up here, if I press the enter key, this is basically going to reload the current scene, okay? If I press play again, you can see I can move around with the arrow keys, and if I press enter, it's going to reload our scene, okay? Now this is just there to act as an analog for when we were switching to different scenes. The same behavior with the singleton is going to be present in both those examples. Now, we also then have our pickups, which are these little objects here, and these are basically have the pickup script, which first of all, we have this little bobbing up and down visual to give it some, I guess, some visual juice. We then have a function which gets called when a body has entered this area 2D. We're basically checking to see if it's the player, and if so, we are accessing the score manager node, which is this node right here, and we are increasing the score by 1, and then of course destroying the node. So in the score manager, this variable is basically ticking up by 1 each time we pick up a pickup. And then finally we have a UI text label right here, which every single frame is basically just updating the text to display score and then the current score number, okay? So fairly straightforward project. Once again, let's play it so you can have an idea of what's going on. We can move around, we can pick up these items. You can see our score ticks up by 1 each time we do that. And if I press enter, this is going to reload the scene, but you could also maybe have it so it goes to level 2, level 3, or so on and so forth. And the main issue we have here is that our score is stuck on 0 again, okay? And that's because everything inside of our scene is reliant on this scene being active. The moment this scene is destroyed or reloaded or unloaded, all the memory, all the player's positions, all the pickups that are alive and not, all of our score, that is all reset, okay? Which is what we want, but we want our score to remain persistent across scenes. So how can we do that? Well, like I said, we can turn it into a singleton. So the first step in setting up a singleton is by going up to Project at the top and then going down to Project Settings. Now, inside of Project Settings, we want to go to the top and we want to navigate over to where we have globals. Now, globals is basically where we can assign scripts to be what is known as auto-loaded. Now, auto-load scripts are basically scripts that are loaded into memory when the game is started, okay, outside of any scene structure. So right now we have none, but what we can do is simply click on this little folder icon to find one. So let's go to Singleton, find our score manager script and click open. And then you can see over here, it says node name, score manager. This is basically what we need to write down in order to access this script inside of our code, and click add. And here we go. So we have the name of the auto-loaded singleton, we have the path to the script, and then we also have this thing here, which is called global variable. And right now it is enabled. Now what global variable basically means is, are we able to access the variables from this script, such as our score? Now, that's the entire purpose of us doing this, so of course we want to enable that. But if you have private variables, you might want to untick them, because you might have a singleton that just has functions you want to access. Okay, but for us, we want to access a variable. So now that we have that set up, we can close this. We can then delete our score manager node here, which contains the score manager script, because we no longer need that. So we can delete that. We can then hop into our scripting. Now, if we go over to the pickup, instead of accessing the score manager node, we are instead just going to write down score manager and then go dot score plus equals 1. Okay, remember, this here is that score manager name that we assigned for the singleton. We can then, for example, just comment this out. And then for score text, we want to set our score manager. In fact, we don't actually need this variable. We can comment that out. And instead, just go score manager.score. Okay, it's fairly easy to access variables and functions from singletons. Okay, and to call a function, you would of course just write score manager and then dot, function name, as you would any other way. Okay, so we can save that, press play, and now that should work as expected. You can see we can pick up these potions. That is going to increase our score. But now look what happens when I reload the scene. The score has remained persistent, okay? And that is because the score manager script is no longer being run inside of this scene tree. Rather, the score manager script is being run outside of the scene structure, okay? It's sort of on an abstract layer above everything else. All right. Now, of course, if we want to reset our score, we will just have to set the variable back to be 0. So those are the downsides, I guess, with singletons. Not necessarily downsides, but things that you need to be aware of. And that is the fact that, since you are having this data be persistent across your entire game, if you want to, for example, reload the game, let's say you go back to the main menu, you start a new game, for example, well, the score would still be 29. So you would then have to go in and manually change those values back to their defaults. Okay, but that's just a little bump in the road. Generally, singletons are a great way, as I said, to have persistent data. Now, don't make the mistake of having every single thing in your game a singleton, as that is generally not the best practice, as like I said, there can be a lot of issues and it can lead to some bad habits forming, especially when you're trying to maintain data in a game. So that is how we can set up a singleton inside of Godot. Hey everyone, in this lesson we are going to be exploring the observer pattern inside of Godot. Now before we jump into what the observer pattern is, let's first of all look at this little project I've set up here. So basically we have 5 different lights here inside of our scene, and if I go ahead and play it, I can press the up arrow to turn them on and press the down arrow to turn them off. Now how do you think I am going about setting this up? Well, if we go over to our scripts, let's first of all look at the actual light itself. We basically have an on and off sprite, and then down here in the turn on function, we're basically just setting the sprite to be on, and for turn off, we're setting the sprite to be off. Okay, so fairly simple here. Now, if we go over to the light manager, you'll see this is the setup we have here. We have a variable keeping track of each light we have inside of our scene. And then down in the process function, we are checking to see when the up arrow is pressed. And when that is pressed, we are calling the turn on function for each of our lights. Same thing for when we press the down arrow key, we are calling the turn off function for each of these lights. Okay, so that is what is giving us this behavior right here. Now, you may be looking at this and going, that's all right. We're simply just getting a reference to our lights and then calling the functions respectively. But this here is what I would call some pretty bad code for 2 reasons. First of all, we are repeating the exact same action many times, which generally in code, if you are doing something multiple times, either chuck into a function, a loop, or chuck it into a signal, okay? Now, with this code, we are also having an issue in terms of scalability and dependency, okay? Every single light we add to the scene, we have to add a new variable to the list here, and then we have to add its turn on call and its turn off call, which, for a couple lights, that's okay, but what if, for example, I wanted to add in 100 new lights to our scene, okay? That would require a lot of code being added to this, and this script would be hundreds of lines long, all of it pretty pointless, okay? So what we are going to do now is explore the observer pattern, and in Godot, we are going to accomplish that with signals. Now, Now, what is the observer pattern? Well, this is a subscription mechanism, but what do I mean by that? Well, you have two things inside the observer pattern. You have the subject and you have the observers. Now, the observers are going to be like these lights right here, and our subject is going to be the light manager. Now, the light manager is going to be basically emitting a signal to all of the observers. A great way to think about this is sort of like a radio tower, okay? A radio tower emits a radio signal, but it doesn't know exactly what radios or what cars or what homes are going to be picking up that signal, okay? Because right here at the moment in our light manager, we need to know all of our observers, okay? We are listing down each and every one of our observers in order to directly communicate with them. That's not what a radio tower does. A radio tower just emits a signal in all directions, and then the observer, which might be your radio, your car, your phone, that then listens for that signal, and then it basically runs whatever instructions that signal carries over. That is what we are going to do here using Godot's signal system, okay? So instead of referencing every single light in our scene here and calling it for each turn on and turn off, we are going to have none of that, okay? The subject, which is our light manager, is not going to even know if a single light in our scene exists, okay? It's going to behave the exact same way for whether there are 0 lights, 1 light, 2 light, or 1,000 lights, okay? And our code is going to look the exact same as well. Now, you may have already used signals inside of Godot before. If we go over to the inspector and click on the node panel, you'll see that we have all of these signals that we can basically connect to our scripts, and that is basically what the observer pattern is, okay? You have the subject, which for example, here you can see we have the node class right here, that would be the subject, and then whatever we connect this signal to, that would be the observer, okay? Because with a signal, you have something that emits the signal, that is the subject, and then you have something that listens for the signal, which is the observer. So let's go ahead and set this up. So the first thing we're going to do inside of our light manager is delete the list of lights we have here. It doesn't look that nice, and we're not going to be needing that. Let's also delete that inside of our process function. I'm just going to chuck in a pass so we don't get any errors here. Okay. And we are then going to create our signals. So we need 2 signals, one for turning on the lights and one for turning off the lights. So here I'm going to create a brand new signal. Now, we've pretty much in the past worked with signals using the node panel here, but these are not all the signals we are limited to, okay? We can create our own custom signals in script. So let's do that now. So to create a signal, we first of all need to define the signal keyword. So we'll go signal, and then a space, and we just want to then give it a name. So here I'll just go turn on lights. Then we can do another one. This one is going to be for turn off lights. And there we go. Now, the way we can actually emit this signal, okay, emit the signal from the radio tower, if you want to follow that analogy, is if we go into where we're pressing the up arrow, we can go turn on lights dot emit, okay? And same thing down here for UI down, we'll go turn off lights dot emit, like that. Okay, so we have our signals, we are emitting and we are, so we're emitting for both turning on and turning off, but if I press play, you'll notice that, well, nothing happens, and that's because our lights don't, first of all, know these signals exist, and second of all, aren't doing anything when they're called. So what we need to do is connect these signals to the light's respective turn on and turn off functions. So to do this, inside of the light script, which is attached to each and every one of our lights, I am going to go ahead and create the ready function, which gets called when the node is first initialized. We then want to get our light manager node, which contains the light manager script. So I'm just going to create a variable here called manager. And this is going to be equal to we can just drag that node in to get a reference to it. And then what we're going to do is go manager and then go dot turn on light. So you can see we have this little signal icon here to know that this is a signal and not a variable or a function. And then we're going to go dot connect and we're going to give it the turn on function. Okay, we're going to do the exact same thing for turn off. So we'll go manager dot turn off lights. So we're accessing the signal now. Dot connect, and we want to specify what function we want to connect it to. So turn off. Just like that. Now, if we go ahead and press play, you'll see that when I press the up arrow key, we have these lights turn on, turn off, and so on. Now, since we are using signals and not directly referencing the variable in the script, we can create as many lights as we wish. So if I want to go ahead, select these, let's go ahead and duplicate them. Let's create a bunch of more copies here. We have a large amount, and again, we don't have to know that any of these exist. The light manager does not know a single light exists. All it knows is that it has a signal it is emitting, and if something wants to listen to that signal, it can, okay? And it doesn't matter if there's one thing listening to it or a million things. That light manager is going to always emit that signal, and anything that is listening, the observer, that is always going to then receive that signal and then run the code respective of that.